Okay. Hey guys, so today we will enter the chapter of the energy system, the MCG 4713, biomass. Okay, so okay, so if we are learning by previous chapter, we go for the solar energy. Okay, solar PV, solar heating, concentrator, meaning that to concentrate or to gain the multiple irradiance for the PV. And today we will try to cover this part, yeah, in week 5. So just this one we are cover week 1 until week 4. Okay? And this part we cover week 5 and 6. Maybe this one is 7 and 8, 9 and 11. But we will try to cover this one by today. Okay? If not, we will proceed for the following weeks. Okay. So basically, what we are trying to learn today is the potential of the biomass resource as a part of the renewable energy to become our potential energy. Okay, meaning that based on this kind of information, renewable only cover 19% compared to the 100%, which is led by the fossil fuel, nuclear power. Okay, this one is the global, it's not the Malaysia, the global energy consumption in 2014. So yet, from the all renewable energy, half of it is modern renewable and traditional biomass. Okay, so and then from that 10% or half of the modern energy, and I would say partially go to the biomass, hydropower, and the rest go for the wind, solar, biomass, geothermal power, biofuel. Okay, so today we will try to cover partially related to the biomass. Okay, so we look, is that possible or is that promising source of energy that we can try to implement in our countries specifically or in a global situation? Because what? It depends on how much or what is the volume you are produced the biomass, so that we can exploit the waste from the biomass or the resource from the biomass to convert become electricity energy. Um, with the okay, so this is the next slide. Okay, non-biomass, biomass, and then most of the biomass been used for the heat building. Secondly, go for the heat industry. Okay, and the rest go for the electricity, transport. Okay, meaning that from the biomass itself have the potential to produce some sort of the energy that we can utilize for the goods of reserve the utilization of the fossil fuel, because from the biomass itself it will give us the, I would say, um, sustainable energy in terms of the resource, meaning that let's say that particular country have the work or industry related to the forestry. So let's say they have the thing that the tropical country with the landed area covered by the trees and everything. So they have to go for the timber activity. So that all the things or the residue or the plantation, the harvesting of the plantation, the residue of the plantation, they can use. Besides, they just dump to the maybe the just go for the dumping. So they can try to collect those residue from the plantation or the forestry activity to become a source of heat. Okay. Okay. So that's the thing. So we have question here. We have the chat here. I have the difficulty to make this. Okay. Difference between traditional biomass and modern biomass. I would say, sorry. Okay, thank you, Aaron, for the question. Well, okay, this one, traditional biomass and the modern biomass. Traditional biomass, I would say, is the direct conversion from the the residue of the plantation to become your energy or heat. But the modern biomass, you need to additional processes from the residue to become your energy or heat specific. Okay, so it depends how you want to make use of your residue or uh, of your plantations, crops, or everything. You can go for the traditional, means that the direct combustion, or you need to process the things to become the energy resource. Okay, right? Okay, thank you for the question. So next, should I just fact and figure? I would say just a fact and figure. Um, just to mention that in the form of the biomass, 77%, according to the 2015 result. 77% is a solid mass. And then the 18% MSW, which is municipal solid waste, biogas 4%, and biofuel 1%. Okay, so that's the portion biomass source in heat generation. Okay, but biomass source in electrical generation, almost is the same. From the solid biomass, 71%, biogas 20%, and MSW 8%, biofuel 1%. So in terms of the either heat generation or electricity generation, biofuel is still there, but with very minimum percentage, which is 1%. Okay, so maybe you are the one who are future engineer can look into this kind of concern to exploit bigger percentage for the utilization of the biofuel as a part of the biomass resources. Okay. Okay, so just to share the pattern or trend related to the biopower generation. So Europe, everything. But the big idea is a very simple. Keep on increasing throughout the years. Okay. So and of course they have a very huge potential because most of the developed country or the modern country go for the source of the biomass as a power global generation. So it's a quite promising source of energy that we can try to improve, try to implement. It's just a matter how good we have all the resources in terms of the prime resource as a part of our renewable energy. Okay, So this is biofuel global production. Okay, so 2015, 74 ethanol biodiesel. That's why it's the chemical process. For the United States, it's the biggest one using this biofuel global production. Brazil, rest of the world, and EU. So United States maybe have the very open space area which is have the plantation. Normally they will go for the corn, right? Corn, the corn. So maybe that's the one of the most potential that contribute to the biomass resource of that particular country, which is United States. Okay, so this one just overview this thing. Global biomass demand. Okay, building, modern building, everything. Okay, manufacturing industry, transport, liquid power, district heat generation. Okay, and just you do not need to remember, it's just to see the pattern, meaning that over the years, okay, so the pattern more or less like the some of the parts decrease, some of the parts is increased, okay, due to the demand on the particular. But the one is the expected 2030. So maybe another 10, that's why 10 years to go. Okay. Meaning that the manufacturing industry will into the biofuel or biomass, also the transport liquid production, also the power district generation. Okay. So those who are entering this kind of industry might see this is about the potential to be explored, to be learned, perhaps. So yet you are the one who are already learned about the renewable energy or the biomass and everything. So then you can have the good opportunity at 2030 because you are the one already know the basic thing related to the renewable energy specifically. And yet this kind of industry, building, manufacturing, transport, liquid power industry, district heat generation will undergo the higher consumption of the biomass demand. Okay, so this is the bioenergy cycle. Okay, I'll try to do this one. Remember that's mentioned at the last class. All the renewable energy, specifically, they go for the two major concern: environmental effect. Okay, that means that the CO2 emission and NOx emission, okay? All the carbon emission that harmful to the public. So, and then of course, due to the pricing, pricing, okay, to reduce or to minimize the cost to generate the electricity and having the free resource from the renewable energy that available at all time. Okay. So maybe we can start with these three. Okay. The difficulty to do this. We try to use the PowerPoint. Okay, so start with the three. That three after some time, then they will become maybe they chop everything, whatever they process, then go for the biomass factory, biorefinery. Okay. Then we go for the things recycled or dump over here as well. Okay. And then produce, so this one is the process of the biomass, biorefinery. Okay. And then the outcome from that biorefinery, they will produce biofuel for the car or transportation, heat or electricity for the cost for the residential, for the grid, and the biomaterial maybe for the paper, okay, paper. Then those things that emission from the car, we go back to the tree, right? And then the residue or the balance or the trash from the paper can be part of the source of biorefinery. So this kind of cycle will continuously support each other. Okay? So that's the idea. But just bear in your mind, even they are doing this kind of part, sun is still there. Sun is still there. So fully integrated agro biofuel, biofuel cycle, and sustainable technology. So that's the thing. Okay, carbon cycle. Okay, in terms of the carbon cycle related to the biomass. Okay, since like Sir mentioned just now, from the tree, okay, photosynthesis, decay organism, okay, dead organism waste, okay, this okay, animal, okay, fossil and fossil, okay, and then all the residue come to the factory, okay, and then factory and vehicle emission, that emission used by the plantation, okay, respiration, okay, carbon organic over here. So that's the cycle of the carbon cycle. Normally they will call this carbon cycle. Okay, so whichever that they are produced, they are using it back. Okay, cycle means that normally we'll go for the closed loop line. So let's say closed loop, either cycle, closed loop from here and back to the original circulation. Okay. Okay, so this the I would say process that relates to the bioenergy technology to produce the end product. Okay. For example, let's say you tend to produce chemical, for example, right? So you may go for the process of extraction, which is your source is from liquid, and the name of the process is the liquefaction. Okay, so that's the thing. Let's say you have the part of the pyrolysis. Okay, so they will go two types, either go for the charcoal or the liquid, and then go for the selective processes to produce your end product. Okay, so that's the basic about the bioenergy technology that available here. Okay, so thermochemical process of bioproduction and the process corresponding product. Okay, biomass resources. Uh, I just want to ask you guys, what do you think in Malaysia, our prime source of biomass resources? Do you have guys any idea? What is the prime resource of biomass resources in Malaysia? Waste material. Okay, thank you, Bazli. Good try. Animal waste. Okay, okay. Palm oil waste. Palm tree. Okay, okay, good. So I think we understand already the meaning of the biomass resources. Because what? Uh, in Malaysia, or specifically in our country, the biomass resource depends on the geographical condition as well. Say uh, our country is in the condition of the hill and mountain landscape, so that we are not having a very large or much related to the plantation, etc. Right? So by having this kind of blessing country, so we are blessed with the green tree plantation, land, and hill for the farming activity, so that all the sources can be used as a part of the biomass resources. So in this case, Malaysia, normally we will go for the uh, palm tree. Okay, palm tree. Thank you, Zahimi Lakman, Hakim, for your answer. Palm tree, meaning that we try to have the residue or the balance or the waste from the palm tree, and yet we produce it to become part of the energy in the form of electricity or heat generation. Uh, it's a very quick view, because that palm tree we only to be specific, we tend to get the oil, right? Oil from the palm tree, oil palm tree. But then the residue from uh, the leaf, the trunk, everything, we can use it. It's a part for the biomass generation. We will look afterward. Okay, before we go further, is that Khalid or G around here? Is that Khalid or G? Is there any potential for the biomass in your country, specifically in Sudan or Yemen, for biomass resource? Okay, we wait the answer from Khalid and G if they are available so that we can know. Is that in Yemen or in Sudan, they also have the obvious resource of biomass energy. Okay, so this is the thing, type of biomass. Okay, plant exclusively grown for their use, everything. Okay, agro-industrial waste. Okay, agricultural waste, all the waste lah. If if I can conclude this, all the waste, just the metal, the solid waste or the liquid waste, okay? Forest waste, sorry, municipal solid waste, okay? Forest waste, energy crop. Okay, so by having these 5 type of biomass, which part do you think Malaysia uh, champion in terms of the resource? We have energy crop, agro-industrial waste, agricultural waste, municipal solid waste, and forest waste. Okay, so energy crops, yeah, we can go for this one. Go for this one. Agro-industrial waste, also this one. Also for this one. Agricultural waste, straw, cereal, pulse one. Crop waste like the sugarcane trash. Okay, so we have them. So this one. Normally we go for the rice husk, because we have so-called the very big area for the paddy field, right? So the rice husk, the factory, everything. So we have the rice husk. Municipal solid waste, I would say this to make it very clear, municipal solid waste is our kitchen waste at our home. Okay, if you throw all your waste from after food, so you eat or your lunch or everything, so you put them in your dustbin. All the thing we call it municipal solid waste, which is your kitchen waste. Okay, your fish, your chicken, or your whatever food that you are not finished. Okay. Forest waste is a logging activity. Okay, so all the shit, bugs, everything, sawdust. Okay, so this the potential resource from the biomass that we can try as a part of the feedstock for biomass power production. So in other words, I'm not sure whether other country have the difficulty to equip this one, but then in that particular country, we will have the geographical condition which leads to the plantation activity. They might be suffer to provide this kind of resource like that, because in Malaysia we are blessed with the good land area so that we can go for the plantation and everything, so that the residue from the activity can go for as a part of the feedstock for the biomass power production. Okay, so that's the beauty of our country. It's just the matter how we as an engineer, how to make use of it by having this kind of knowledge or information, so that you become the future engineer, can suggest or can propose the most suitable approach so that can earn the benefit by this kind of resource. Uh, if I'm not mistaken, there is a country, if I'm not mistaken, sell the waste from their country to the other country, because um, maybe they do not go for the biomass producing energy. So the excessive waste, for example, forest waste or energy crop or everything, they sell to another country to get the benefit. So yet they can clean their country, and at the same time they gain money, and at the same time the country that buy that waste also can produce energy by minimum cost. Okay, so that's the scenario. So that's the part. Okay, so proceed. Biomass resource. Okay, as Sir just mentioned just now, energy crop, waste product, okay, agricultural residue, animal manure. Animal manure, okay, yes, we have, but not in a big scale. Normally, they will go for the farming implementation by their own area. Okay, they go for the animal manure to produce uh, the fertilizer, etc. But then there's not much huge quantity of the animal manure. Okay, resource of biomass in Malaysia. Yes, palm biomass. Okay, domestic waste, effluent slush, agricultural waste, or wood chip. Okay, so we will try to focus this one. Palm biomass. Okay, biomass palm oil byproduct. Okay, so from the palm oil plantation industry. Okay, what is the agency in Malaysia that in charge for the oil palm oil plantation? So this one is the general knowledge for you guys. So what is the agency that in charge or responsible? MPOB, okay. Malaysian Palm Oil Right? Okay. Anyone else? Anyone else? Anything beside the MPOB? Okay. Good, Rosalie. So MPOB is one of the body that concerned or in charge or responsible for the palm oil in Malaysia specifically. Okay, they go for research. Okay, they go for uh, try to explore the new finding related to the advantages or byproduct or anything that leads to the good of the palm oil industry. So, okay, while we're waiting for the others, so from the palm oil tree, then they have the, of course, palm frond, okay, I would say the pelepah lah, palm frond, okay. They have the palm trunk, okay, the punya batang of the tree, okay, palm trunk, and they have the mesocop fiber, the I would say how you call that, the covered of the seed, the cover of the seed in the so mesocop fiber, and that's the palm kernel shell, okay, palm kernel shell, meaning that the shell of the mesocop fiber and the seed of the palm, and also the EFB. Normally they call it short name EFB, empty fruit bunch. Okay, EFB, empty fruit bunch. Meaning that all the uh, seed from the oil palm will be removed and everything. So the empty fruit bunch is collected here, and yet the palm oil mill effluent, which is the process, okay, the process for those activity to convert it from the oil palm. So the slush will be go in the ponds to ensure it not affect to the public. So in other words, by having this one tree of palm oil, they have the residue or the balance or the bypass product which can be used as a part of the end. So that's why Malaysia go for this kind of plantation, which is the oil palm, because the byproduct from itself can be used mostly 100% to become biomass source. Okay, so percentage accordingly. Okay, the palm biomass portion in Malaysia. Okay, so the most is a 70%, which is the empty fruit bunch. Okay, EFB. Okay, followed by front. Okay, and then fiber, trunk, and shaft. Okay, so that's why normally when, at that particular industry, beside they have the oil palm to produce the oil palm, they also have the facility to produce the energy by using the bypass product from the oil palm tree. Okay, so yet they will go for the better saving because they can use all the heat generated by the byproduct maybe to power the process of the producing the biofuel or any oil from the oil palm tree. Okay, so this is the state oil palm planted in Malaysia. So if you can see, we can just go through. But the one is in 2020, it might be changes from time to time. But then we can have a look. It's a huge potential for each state. Besides release land, this seems like a very small percentage. Then okay, this do the maybe the area itself and the place and the Penang. Okay, but then Johor, you can see there is Pahang, okay, Sabah, Sarawak have the huge potential to exploit the advantages of the oil palm for their energy resource. Okay, so this is the governing agency, MPOB, Malaysia Palm Oil Berhad. Okay, thank you. As Fazli Nabil answer. Okay. So that's the potential. Okay. So this is the thing that Sir tried to ask you guys just now. Okay. Beside the MPOB, the main palm tree ownership in Malaysia, we can go for maybe Delta, the highest one. Also, private state is okay. Private state instead, maybe, for example, let's say Samdabi, okay? Samdabi plantation, okay? So and others. So then Felda, okay? The punya smallholder state agency, Felda, and so. So of course, when they go for this one, they have the team to look at the potential of this kind of the oil palm plantation or oil palm resource as a part of the biomass energy. Okay, okay, so the typical palm tree and FFB. Okay, so palm frond. Okay, so this is the palm frond. Okay, okay, so who is this? These people, not monkey. People. Palm trunk. Okay, palm trunk. Okay, kernel. Kernel is the black one. Okay, kernel. Shell is the shell. Shell. I want to show you. Okay, so this is a fresh fruit bunches. So fresh before we peel off the seed, when after we get all the things, become EFB, empty fruit bunch. Okay. At the tree or before we peel off the fruit or the seed, we name it is a FFB, fresh fruit bunches. Every year for 30 for 40 new leaf, palm frond are grown, meaning that guys, um, by while you are waiting for this or palm tree matured. So during the meantime, all these palm frond will be grown a new leaf which is around the corner from that particular tree. Okay, so by having that kind of excessive palm frond, where we can take that as a part of the energy resource. First crop fetch is 5 to 6 after plantation. Each tree can provide palm fruit for 25 until 30 years. Okay, when it fruit ripe, it turns to orange red. Okay, so this is the thing related to the palm tree. So that's the part. Okay, rate of fresh fruit batch produce. Okay, so one is first state in 2010. Okay, Kedah, okay, the whole everything. So this is the just to show that rate of produce FAB in different state. It's a quite high related to the accordingly to the big uh, state. Okay, for example, let's say Pahang, let's high. Sabah Sarawak, is that? Okay, Sabah, Sarawak, okay. Maybe due to the hill area or something. But the big idea of seeing this, all the states have the potential to use the oil palm as a part of the biomass resource. Okay, just a matter how big, what is your scale of if you want to produce it. Okay, so next, creating energy biomass from biomass. Okay. So this is the summarization of the bioenergy conversion. Okay. For example, okay, so we mentioned the things that we are not cover for our class, which is related to the chemical. So let's say for the chemical, okay, so this is the thing. Okay, this is the thing we are not cover because it relates to the parts of um, chemical parts lah, aerobic digestion, anaerobic digestion, okay, alcoholic fermentation. Okay. So that's the thing that we are not cover in our class. But then, biomass a chemical energy, wood, okay, for product or waste, whatever, sewage, moist, okay, and this the thing. It can be divided into a three group of thermal, biological, and mechanical. And mostly we will go for this thermal, okay, this for this. And from the thermal, we have three types of the category or process, which is combustion, pyrolysis, and gasification. And then, of course, for the combustion, we are using the hot gas, okay? And then application for the heat exchanger, okay? And go for the thermal application. For the pyrolysis, we can go for three types of source, either in a solid, liquid, or fuel gas. And of course, each product or co-product have their own dedicated process to be used. But I think it's a quite good advantage to have the pyrolysis because we can have the option to produce in the form of solid, liquid, or fuel gas. Uh, Compared to the combustion, we go for the only for the hot gas, which is we are burning the thing, and the hot gas we go for the heat exchanger, as well as the gasification. Okay, we go for the fuel gas as well, and then go for that kind of producing the mechanical, thermal, chemical, electrical processes. But by having the pyrolysis process, we can go for three type of waste, either in solid, liquid, fuel gas. So we give the more option compared to the combustion and gasification. And yet, after that, after purifying and upgrading the fuel, everything, So we can go, this one is more into the application where we want to place all the resource, right? So of course, it will have the range of the producing the energy, but then you can go for the implementation of the steam turbine, okay, combustion engine, gas turbine, fuel cell, combined cycle. But all the best idea basically want to produce the electric generator and then go for the electric motor and then go for the any appliances or thermal appliances or mechanical appliances, okay, and electronic or luminous. Okay, so that's the basic idea. In terms of the biological part, so just goes through it quickly. In form of the biogas and methanol. Okay. So yet you go under this kind of part, chemical, thermochemical, electrical processes, and we'll do the same thing, like the thermal or like the uh, wood or the co-product or waste. Okay. So yet the aim still the same, just to supply the power for the steam turbine, combustion, gas turbine, fuel cell, and combined cycle to produce the electric generator, and also go for the application for thermal or mechanical. So that is a basic idea of the bioenergy conversion using all the biomass product. Sorry. Okay, direct combustion. Direct combustion means that we directly burn all the waste, the burning of biomass in air, convert the chemical energy stored in biomass, various items of process equipment, produce hot gas, feasible only for biomass with moisture content less than 50, unless the biomass is pre-dried. Okay, so this is the uh, attribute for the direct combustion. Okay, so it's a very basic. So we enter all the things from here, bill handling, okay, put all the things in the conveyor, okay, insert things, okay, and then go to be burned, and then okay, so and then burning, and then the combustion chamber, in the combustion chamber, and then high pressure steam, okay, and then go for the outward to the steam turbine to operate to try to generate the electricity through the generator, okay, and the accessing air will be go in the condenser and going back to the feed water. So this is the feed water, the source water, and going back into the chamber, and then go inside the bed filter, okay, and then maybe partially they will go in the form of the ash, okay, partially go to the fan, go to the atmosphere. So that is the basic concept. Straw feed power station uh, in terms of the direct combustion. Okay? So if the assessing not go for the high pressure, number 8, they will just go straight, wait for the high pressure to be filled up directly to the tank filter. Okay? Then the tank filter will go for the producing the ash, and at the same time partially go for the emission. It depends how it's work related to the process. But this one is not the standard. I would say it's a must design. You can custom by your own according to your intended resource of energy. But then this is the basic principle for the direct combustion. Okay, pyrolysis. Uh, just is the direct combustion. This one is the pyrolysis. Direct combustion is that. This one. So combustion. Okay, so now pyrolysis. Combustion biomass to liquid, okay, liquid, solid, and gaseous fraction. Okay. We keep mentioning the bio oil, solid, a charcoal, or gaseous. Within the biomass is the absence of the of air to around 500 degrees C. based on the thermal gravity again, thermal gravity analysis, testing biomass, there are 3 stages. Okay, there are 3 stages: pre, second stage, and last stage. This is the range 100 until 200. Okay, slightly weight loss, so some internal rearrange such as bond breakage. Okay, the second stage, main process, solid decomposition occur, significant weight loss. And last stage, continuous charge revolatilization caused by the further cleavage of carbon, hydrogen, and carbon oxygen bonds. Can be divided into fast, intermediate, and slow pyrolysis, depend the reaction temperature and the residence time. Okay. So that's the basic operational related to the pyrolysis. We have a 3-step of pre-pyrolysis, second stage, and also the last stage. Okay. Maybe you can put in this form to make ourselves clearer in the form of the pyrolysis process. It can be divided into 3: charcoal, which is the solid, oil is the liquid, natural gas, the gasification. And this kind of charcoal, this is the thing that are required. Okay, so this is the thing that are required. This is the thing that are required. But from here, we can see that the recommended might be the bio oil and the fuel gas, because for the charcoal, up to the 30% yields, meaning that the carbonization is slow pyrolysis. Okay, but for the bio oil or the fluid and the gases, up to the 80% yield. Okay, so meaning that the waste of the process are considerably low compared to the charcoal, which is up to the 65%, which is converting to the maybe to the emission carbonized. Okay. So this is the I would say the breakdown for the pyrolysis compared with the gasification. For the, if you notice, we have a fast, intermediate, and slow. Also the gasification. Okay. So this is the condition. This is the condition. Moderate temperature, okay. Moderate temperature with the percentage of the liquid, gas, and solid. Intermediate. So it depends. If you go for the intermediate, you may get this kind of portion of your end product. If you go for the slow, you may have the more or less the same portion of the liquid, solid, and gas. So it depends how you want to check your output or your outcome from your pyrolysis process. Okay, moderate temperature around 500 degrees C, short hot vapor resident time 1 second, 10 to 20 seconds. Okay. Slow around 400, very long solid resident. So that's the thing. So anaerobic digestion, so just skip this one. Okay, so just skip this one, anaerobic digestion. Because it's more like the more on chemical side. Biomass and waste power. Okay. So biomass and waste installed previously for power generation projected 2010 to 2025. Biomass and waste power production. Increase of the trend from time to time, and that covered the rest of the world. Okay. And also include Brazil, China, US. So, but the big idea to the pattern or the trend to use the biomass and waste increase from time to time. Okay. So next. So what time we have now? Okay, we have 51 participants. So now is Okay, 10 o'clock. So I think we can still have this one. We'll try to check the slide. Have still a lot. So we have another half of it. Oh, okay, not that much. Some of you. Okay, so we try to proceed this one. Some of you try to stop at 10:30. Okay, because another 30 minutes we will go for the uh, briefing assignment. Okay, guys? Okay, thank you. Uh, okay, so this the so we proceed this one. So we try to complete this one by this remaining 30 minutes. Okay, okay, so one. Sorry, need to move this one. This one. Okay, better. Yes. Okay. Biofuel. Okay. First generation of biofuel, second generation of biofuel, and petroleum refinery. Okay. So this I would say the comparison of the first, second generation biofuel and petroleum fuel. Okay. So I to example. Okay. So petroleum refinery, crude petroleum, product, CNG, LPG, diesel, petrol, kerosene, and everything. Problem, depletion, environmental pollution, economic and ecological problem. So yet we go for the first generation fuel, then energy, economical, feedstock, vegetable oil, corn sugar. So corn sugar, that's the thing that I mentioned just now. Maybe this is the most major contributor for the US for the corn and sugar as a part of the feedstock. Okay, and also the vegetable oils. Product, fuel or biodiesel, corn ethanol, sugar alcohol. Problems, a limited feedstock, of course, blended party with conventional fuel, partly with conventional fuel, benefit environmentally friendly, economic and social security. So that's the transition from the petroleum refinery to the first generation fuel. They try to go for the corn sugar or vegetable oil as a part of the source of oil. And then second generation biofuel, feedstock, non-food, cheap and abundant plant-based biomass, either in the form of the agriculture, forest residue, grass, aquatic biomass, water, okay, product. Okay, so bio oil, FT oil, all the things related to the chemical parts. Advantages, not competing with food, okay, because there's the another source of waste. Okay, advanced technologies still under development to reduce the cost of conversion, environmental friendly. Okay, so that's the comparison between the petroleum refinery, which is our main source previously, and we turn to the generation of the first generation. We convert the oil from the vegetables or corn sugar, and then afterward we go for the biomass waste as a part of the feedstock. Okay, where biofuel production, yeah, as I mentioned just now, it got keep on increase, but still not that high. Okay, but I would say it's a good or promising technology. So this one, Russia, Europe. Okay. So America, this one, 2015. Okay, so this is the rough idea, the potential of the world biofuel production, okay, from time to time. from time to time, okay, according to the region. Okay. So yet, rest of the world is quite high, quite high. Okay. So hopefully, uh, we try to go further, because of course this kind of part will affect our country, and we also uh, have a huge potential based on our oil palm industry. Okay. But if you have noticed, there are some of the issues related to the claim that the oil palm is not that efficient or not that good for the application of the energy, etc. But then maybe it's the strategy, the strategy to interfere the market or potential of using the pump as a part of the source of energy. Okay, so biodiesel, okay, is substitute of the diesel, but more friendly in terms of the content produced through the transesterification of the vegetable oils, the CD oil and fat, minor engine modification, has significant influence in reducing engine emission, such as amber, hydrocarbon 68, particular 40, or SO, sulfur oxide, polychloric, aromatic hydrocarbon. So high significant influence in reducing engine emission. So that's the beauty of the biodiesel. Because the diesel itself, they have the carbon emission is quite relatively high. So by having the biodiesel, it might reduce the harmful emission, which is part of the carbon. Okay, so this is the conventional feedstock and conventional. Okay, so but we just see the biodiesel, which is the conventional feedstock, soybean, canola, okay, bunga matahari, canola, brassica, cotton, groundnut, pumpkin, jojoba. Okay. So why not in the list we have the oil palm? Okay, so that's the thing. That's the thing. So we as an engineer, for the future engineer, so we need to go for the more investigation or research related to the oil palm, because it should be somewhere around have the potential to become a part of the feedstock to produce the biodiesel. Okay, but not in the list as you've seen here. Production of biodiesel, direct blending, so equal emulsion, catalytic cracking, transfer certification. Okay, so I'll just skip this one. Bioethanol, so I'll skip this one. Bioethanol properties, okay, properties of this one, just skip this one. Global ethanol production, okay, skip this one. Biogas, okay. Biogas, a fuel that can be used in gasoline vehicle with slight adaptation. Okay. So previously it's a biodiesel, for this time it's the biogas. Gasoline vehicle, which is using the petrol, produced through anaerobic digestion of liquid manure and other digestible feedstock. All biomass, including industrial, agricultural waste, cellulosic waste, crop residue, microalgae. Okay, so this is the biogas part, what we can try to use to support of the energy resource. Okay, so this is the global benefit of renewable energy, specifically in general. Okay. So let's say we go for the political. Let's say you is the ministry of certain country, okay, and then you start to fight for the usage of the RE in that particular country. So yeah, you can get this one, win, heart, and minds. Kan? Okay, and big power and action, okay, created actor in a renewable energy powered future. Okay, so if you are become political, and then for the environmental, uh, of course, when you apply the renewable energy, so GHG or greenhouse gas emission reduction, okay, increase in environmental value and behavior. Okay. So this is the thing that we get. And then it's a part of the economy, shareholder income, community income, local job. Of course, let's say you want to produce one of the factory related to the biomass. Okay, so you get the shareholder income, community income, meaning the people surrounding to develop the work or the shop, everything, the supply chain of the product, and yet you create a job opportunity for the people surrounding uh, your area. Yet you become the community asset, regional development, income diversification. Okay? So when we go for the looking for the economy, if you're looking for the technological, okay, so energy self-sufficiency, renewable energy industry development, and yet we go for the renewable energy education and training. So, sir, this part, renewable energy education and training, okay, very technological. Yeah, you guys maybe this one lah for economic, community asset, regional development, and income diversification. For social, for public, community building and empowerment, local ownership and decision making. Okay, so depends where are you in this chart, but of course every part, either political, environmental, economic, technological, and social, have their own benefit. Okay. So sir is here, renewable energy education and training. Okay, so maybe you guys somehow over here, maybe somewhere of you somewhere over here. So let's do our role just to ensure that can have a good benefit by using the renewable energy resource. Okay, environmental issue, air quality, okay, we reduce NOx or nitrogen oxide or silicon oxide, sulfur oxide emission, because these two emission is a harmful gases, which is not good for the public, global climate change, low or no increase on CO2. So this one is related to the Kyoto Protocol, okay. And then maybe the Copenhagen Act related to the concern of the emission of CO2. Okay. And then the soil conservation, yes, soil erosion, control, nutrient retention, conservation, stabilization of riverbank, water conservation, and biodiversity and habitat. So that's the environmental issue. Okay. So just imagine the biomass. It's not the thing that the tree we are cutting or chopping the tree. We are using the residue, okay, residue of the plantation after we get all the fruit and everything. Yeah, it's not the we just uh, grow the tree and we chop the tree and then we go for the biomass. That's the wrong philosophy of the sustainable energy as well. Okay, economic issue, more towards sustainable production, energy security, rural economic growth, and use better balance and use. Okay. So this is the thing that concern related to the economic issue. Economic impact in Malaysia, utilization of palm forest and palm oil meat, harmful emission reduction, okay, fossil fuel conservation, okay, by having another option of the energy resource. So we have the better conservation of the fossil fuel, mitigation of the dependence on the fuel imports. Okay, so we reduce the import of fuel from others, cultivation of non-farming area. Okay, so this is of course by social impact, providing the employment, also deliver a valuable benefit to the rural community. Okay, people surrounding at that particular industry. In case of the things that we concern, is that the policy environment. Okay. So from the policy environment, we need to consider is a part of the challenge to the biofuel, which is should we provide the supportive policy, the regulation, lower volumetric energy content, okay, recent fuel economy and GHG emission regulation, transparent independent price signal are essential. So that's the challenge to the biofuel. And then of course, related to the technology itself, technology challenge for second generation biofuel, which is the non-food biomass. Okay, also residue, forest biomass, decomp, MSW, for location with consideration. Okay, so this is the challenge to prepare to be implemented as a part of the biofuel resources. Infrastructure as well. Okay. So of course, if you want to make it a closed cycle or the cycle with a good supporting each party, we need to provide the infrastructure as well so that we can have a continuous chain of support each other to sustain the system of using the biomass as a part of the energy resource. Okay, if there is only biofuel light available at large scale, okay, E85, 50% gas oil in gasoline, flexible fuel vehicle, with the greatest near-term consumption, enhanced biofuel capability, and adequate lead time is required for vehicle manufacturer. So of course, it's not only the producing the biofuel, but also the car that suit or fit with the condition should be considered as a part of the supply chain or a part of the circle to sustain or to promote the usage of the biofuel effectively. What time now? Okay, thank you guys. So we end the session of the biofuel. Sorry, biomass. So we stop.